All right. So um, this time I'll not power anything, but I will explain a principle, an idea. Before I get to the idea, check this out. I have the bucket with water for problems. So when I said I will keep my bucket with water near me, I was very literal. All right. So and that is this green sheet cloth. It should be actually with water, imbibed with water, and just put it like this there, and we'll hopefully we'll keep the fire, but it's not really the case. But I was thinking for the worst, you know. I prepared for the worst, basically. And if everything else failed, I was planning to take everything and put it in the bucket of water together, everything there. Of course, I took it out from the from the current, from the socket, yeah, without the power. But that was my plan. If it was bursting with flames or everything, because I have here some paper, and I know I'm crazy, but yeah. Who knows? I also tested it before I filmed everything, and it seemed okay. I checked the paper if it was burned, and I also checked the plastic if it was burned, because I showed you before. I literally constructed that little plastic thing. Before I start anything, I hope I will not forget about these two wires. You see, so it's having 4 wires. This module, with this heating module that I have, the 2 wires here for the 220 volts, and these other 2 wires that are actually the sensor wires, and I think to use them somehow, even with an op-amp, and I think an op-amp will fit for this application perfectly. But I'm not sure, because I noted here if I should build it with a 555 or a PIC 12F5Y8, that I have a lot of them. They are very cheap, and the idea of the project. I already passed 3 minutes and I didn't say the idea. What I plan, what is my idea is, you've seen me when I was plugging it in and out, in and out, in and out. Okay, so this is the manual, the manual way of keeping that wire not too hot, you know. But I want to create a pulse. You see this pulse? A little bit on, then off, a little bit on, then off, and so on. And that's why I'm putting there the 555 oscillator. Actually, it's to make an oscillator from that 555, or with a PIC F508, because on a PIC I will be able to actually use most probably these 2 sensor wires as well. But you know, it's very interesting to try it with an op-amp and with 555. The non-digital way, what is called I forget the name. I always forget the name. The analog way with 555 and an op-amp, because I still want to learn the op-amp. Actually, I will power it for you, and I will take it out. 1 second. This will be very fast actually. And yeah, I have the plastic is also with fillet. Okay, I was yeah, nothing really melted there, so it's good. You can see there in the little screw holder iron. Okay, so these are the wires from the temperature sensor, and this, where are you? Here, do you see this little dick here? It's like a little dick. That little dick is you see, with a ball on it. That is the actual sensor. That little ball is a difference of if I remember correctly, there are two different wires. One is made from one material, from one type of metal, and another type of metal, and the difference between the two is giving a resistive output or something, and that resistive output is measuring the temperature, if I remember correctly. But we will have to check the theory and how it's made exactly more later. Okay, now yes, I want to show you this one. It's very large, it's very big, because I have you see here, I'm not sure if you can see it. It's a little line. You see this little line? This is actually a wire, a copper wire, and here is the same, another copper wire, and here as well. Yes, there, and here as well. Here and here no, is just normal wires, but those wires are for if something will blow up, they are like fuses. They you know, and yeah, I didn't prepare anything. Shit. Yeah, I didn't prepare anything for it, but trust me on my word, I tested this circuit before, and it's exactly this circuit. Actually, I copied this circuit and I made it here again with my components, and they are exactly the same components as here, the same triac, the same diac. This blue one is a diac, and two capacitors there. Actually, I put bigger capacitors, more for 600 volts here. I think these ones are for 400 volts, so mines are better, and also a very big resistor there for higher wattage, and a little button, and a potentiometer, which is this one. My potentiometer is old and shitty, but it's good enough. It's doing its job. And this is a rectifying bridge, which I made from diodes, which I'm not very proud of, but it's there. It remained there. Okay, so I basically is the same circuit. You get it now, okay? This is the commercial, and this is my testing circuit for a lot of shit that I tested, especially for 220. If I had to, like a little, well, not that little, this motor. I was testing this motor, and it was very curious. This motor was working on 220 volts. It's actually saying here somewhere 220 volts. You see, to 240. At 50 hertz. So this is the motor that I was testing long time ago, but he is actually a DC motor, so 220 volts DC. That's why I have this rectifying bridge here at the end of the entire circuit. So the 220 volts is doing all this job here until here, from here is transformed in a DC current and powering my my motor here. As you can see, these wires are exactly for this, you see, to fit there. And that's what originally this thing was. But I tested this element, this heating element, with this circuit, and it worked perfectly. I tested it with Mr. Steve. He helped me immensely, and it worked perfectly. Of course, I must be careful not to put that potentiometer to an extreme, because it will blow up. I didn't test it to see if it's blowing up something or not, but I don't want to find out. So I will make a stopper, physical stopper, going from here to here, and that's it, physically. And but that is in plan. What I plan is to use this circuit with the potentiometer and power everything, but I also want, if it's getting over, if it's reaching a certain temperature or a certain value of the potentiometer, probably we'll start this modulation. Will not modulate every time, because if it's lower voltage and it's not that hot, it's okay. But this modulation that I was talking about before in the start of the video, this modulation is when this nichrome wire is getting extremely hot, when it's bending. Where is the bending? When it's doing this thing, and to protect it from bending and from getting that white hot, I want to make it like I did it manually with the plug, right, this, like I did it manually, like this, on, off, on, off, and I want it to be with a potentiometer. I think it's best to have two potentiometers, both for how much to stay high and how much to stay low, because I will tweak it and actually make a paper and with inscriptions on that paper at which number the intensity is the best or something, especially for melting solder, because this is all about this entire project is about melting solder from all this pile of shit, without this hose here that I was making some experiments. I was thinking on something else to attach the hose to the blower here, to attach a hose and from ventilator somewhere else, and this heating element, an idea. It was an idea, but those boards are damaged, are from garbage, physically from garbage, but they didn't catch any garbage on them. They are full of dust and mud, but that's it. No tomatoes or shit on it. It's not smelly at all. It's just dusty. Which actually I washed them. I didn't wash them, but I washed something directly in water. I put it there and take it out. But something else, not that. All right, so that's it. I want a circuit that will do this oscillation, and with two potentiometers, and possibly two variants, with peak or analog with an oscillator made from most probably with a 555, and an op amp or a couple of op amps. I hope we can put an op amp for the thermometer. Who knows? But I think with PIC 12F 508 I will do everything, both reading the temperature, both on the potentiometer and everything, or two potentiometers. I'm not really sure. I want your opinions and tell me what is the best. I hope you understood why I want this oscillation, because of that super extreme red hotness when it's at the extreme, at the maximum, almost the maximum. Yeah, no, really at the maximum actually, or very, very, very close to maximum. You know, to take care of it and you know, tweak it until it's not dangerous to broke itself. That's my real reason. I don't want it to broke itself, because it's kind of, you see how loose. Yeah, you see. When I bought it, it wasn't this loose at all. It was very straight, no, not straight, you know, very fit on this white isolator here. But yeah, shit. This is my potty, my thing that I put and took fire here. The black thing here is a little gap. It entered in that gap, and that's why it's still there. I couldn't take it out, and I was afraid not to damage the sensor, the temperature sensor, that is the little dick here. Okay, thank you very much, and really expect some opinions, some ideas on a way to make it. I kind of think I can make it myself, but really I need some brainstorming before starting and doing some stupid thing myself. It's better to have no shame, of course, from my part, to ask and receive help and actually build it after your designs. Thank you, and don't be afraid. I'm very careful with power and fire and everything. Don't be afraid of that. I'm very, very, very careful. I have my trusty bucket here. I trust it very much. All right. Thank you very much for listening, for saying, and for your advices. And I really appreciate your advices. You know that. Thank you very much, and see you later. Hear you later, or read.